The river begins at the Chameyangdung Glacier, a high-altitude ice field in southwestern Tibet. From this source, the water flows east across the Tibetan Plateau for 1,700 kilometers, known as the Yarlung Tsangpo. The Himalayas act as a massive physical barrier to the south, keeping the river trapped at high altitude, preventing it from reaching the ocean. To escape this plateau, the water must eventually break through the highest mountain range on Earth. The river finds its exit at the eastern edge of the Himalayas, near the peak of Namcha Barwa. Here, the river performs the Great Bend, a sharp U-turn where the channel suddenly shifts direction to drop thousands of meters through the mountain range. The plateau stream transforms into a high-velocity torrent as it enters India's Arunachal Pradesh, where it is locally called the Siang or Dihang. The energy generated by this massive drop in elevation allows the water to pulverize mountain rock into fine sediment. In this first stage, the river functions as a geological saw, carving a path through the world's highest mountains. The water leaves the steep gorges of the mountains and spills out into the flat plains of the Assam Valley. In these lowlands, the river meets two massive tributaries, the Dihang and the Lohit. Here, these channels merge, and the river is officially known as the Brahmaputra. The volume grows as the main artery receives the Subansiri and Kameng from the north and the Dhansiri and Kopili from the south. This network of confluences transforms the Brahmaputra into one of the most sediment-heavy mega-rivers in the world. As the land flattens, the current slows. The water no longer has the velocity required to carry the millions of tons of Himalayan rock it has ground into silt. The river drops this sediment directly into its own channel, obstructing the flow. This forces the water to split and weave around the new sandbars, creating a wide, braided network. Centuries of this sediment accumulation built Majuli, which is now the world's largest river island. The inhabitants of Majuli have adapted to this environment, using stilt architecture to keep their homes above the annual monsoon floods. While the silt provides fertile soil for agriculture, the river remains volatile, frequently shifting its banks and eroding the very land it previously built. In Assam, the Brahmaputra acts as a constant engineer, building and reclaiming the ground beneath its inhabitants. The river eventually turns south into Bangladesh, taking on its third identity, the Jamuna. This map shows the Jamuna merging with two other major river systems, the Ganga, known here as the Padma, and the Meghna. This final channel carries the combined discharge of three major river systems south toward the coast. This convergence marks the final gathering of the subcontinent's eastern Himalayan runoff. The river system finally drains into the Bay of Bengal. The sediment carved from the Himalayas and carried across three countries is finally deposited here, forming the mangrove forests of the Sundarbans. This continuous deposit of silt has created the largest river delta ecosystem in the world. From carving mountain gorges in Tibet to building islands in Assam and deltas in Bangladesh, the Brahmaputra remains the primary force reshaping the geography of the subcontinent.